Good morning, my dear students. Today we will continue the chapter Study of Sounds. We have finished what is an echo in the last class. Let us revise that before we go to the next part of this chapter. Echo point, right? You must have visited an echo point at a hill station. If you shout loudly at such a point, you hear the same sound just after a little while. See that sound which is reflecting back after a while. This is called an echo. This sound is called an echo. An echo is a repetition of the original sound because of the reflection of some surface. Yes, recollect once again. This sound is called an echo. An echo is a repetition of the original sound because of reflection by some surface. Just observe how the sound gets reflected. In order to be able to hear the original sound and its reflection distinctly at 22 degrees Celsius, what must be the minimum distance between the source and the reflecting surface? How we hear the sound echo? Because of the reflecting surface. In order to hear this echo, the original sound after its reflection distinctly at 22 degrees Celsius. We know that velocity of sound depends upon three factors. What is that? Can you say? Temperature, density, and molecular mass or molecular weight. Therefore, as the temperature increases, velocity of sound increases. Can you recollect? Yes. Yes, velocity of sound is directly proportional to the square root of temperature. Therefore, at 22 degrees Celsius, what must be the distance between the source and the reflecting surface that we are going to calculate? At 22 degrees Celsius, the velocity of sound in air is 344 meter per second. See how the sound reflects back. Thus, for us to be able to hear the distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. We know that it takes sound remains in our ear 0.1 second. Therefore, thus we can determine the minimum distance between the source and the reflecting surface as follows. Distance is equal to speed into time. That is equal to 344 meter per second into 0.1 second. That is equal to 34.4 meters. Thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the value, half of 34.4 meters, which is equal to 17.2 meters. In the last class, we have finished the audible sound range. That is, normal human ear can hear a sound range of frequency 20 hertz between 20 hertz to 20,000 hertz. Right? So, sound waves of frequency smaller than 20 hertz are called. Can you recollect and tell me? Yes, it is infrasound. And sound waves of frequency greater than 20 hertz are called ultrasonic sound. In the last class, you have studied the applications of ultrasonic sound. Yes, the uses of ultrasonic sound in the last class. And also, you have studied the dog, mouse, cat, and dolphins have the special ability to hear ultrasonic sounds. And children under the age of 5 years age and some other insects also can hear sound waves of frequency up to 25,000 hertz. Yes, that you have already finished in the last class. What are the other uses or applications of ultrasonic sound? What are they? We have studied that for communication between the ships and sea, and in industries and in medicinal, and to sterilize all this in the medicinal field, etc. Now let us see more the uses of or more applications of ultrasonic sound, which is sonar. Yes, SONAR. Understand what is sonar? Sonar is an acronym for sound navigation and ranging. SO stands for sound, NA stands for navigation, and R stands for ranging. So, what is sonar? It is an acronym for sound navigation and ranging. It is a short form of sound navigation and ranging. For what it is used? It is used to, can you say what is used to determine the direction, distance, and speed of an underwater objects with the help of ultrasonic sound waves? Sound navigation and ranging. Remember this. Sonar measures the distance, direction, and speed of underwater object using the ultrasonic waves. Here you can see the ship. There are 2 points which is given, red mark and the green mark what is given under the ship. That is, so ultrasonic sound waves can use to find the distance, the direction, and also speed of underwater objects. Sonar consists of a transmitter and a detector. As I told you, see, red is the transmitter and green is the detector. See, transmitter and the detector. How can this work? It is installed in a ship or a boat. The transmitter produces and transmits the ultrasonic waves. The transmitter produces and also transmits the ultrasonic waves through the water to the underground of the sea. These ultrasonic waves travel through the water. Ultrasonic waves can travel through water, solid and gaseous. So these ultrasonic waves will travel through the water. They get reflected after striking the object on the seabed. What happened? These ultrasonic sounds gets reflected after striking on the at the seabed. These reflected waves are sensed by the detector. These waves are sensed by the detector. The detector converts ultrasonic waves into electrical signals which are approximately interpreted, which are appropriately interpreted. So these detector converts ultrasonic waves into electrical signals and then these are interpreted. The detector converts ultrasonic sound waves, see the machine. The time interval between the transmitter and reception of the ultrasound is recorded. So we can record what is the time taken between the sound, ultrasonic sound waves transmission and the ultrasonic sound which is received. This can be recorded. If we know the time taken for the sound ultrasonic sound wave to reach down and come back to the detector, and if we know the time and if we know, now we know what is the speed of sound. When we know the speed of sound and we know the time, we can find what is the distance between the ship and the seabed. By knowing the speed of sound in water and considering the above time interval, the distance of the object that reflected the sound wave can be calculated. How can we calculate? By knowing the speed of sound in water. We must know what is the speed of sound. If we know the speed of sound in water and the time interval, that means the time taken for the ultrasonic sound wave to transmit from the transmitter and it come back to the receiver. So that time taken is to and fro distance, to and fro traveling time, isn't it? So if we know the time, then the distance of the object that reflected the sound wave can be calculated. Sonar is a technique used to determine the depth of the sea. So in this way we can find what is the depth of the sea. Depth of the sea means distance from ship to the seabed. So the total time taken, and if we can calculate, then we can take what is the half of the time taken. That half of time taken into speed of sound in water gives what is the distance. Distance is equal to speed into time. We can multiply and find what is the depth of the sea. Not only the depth of the sea, we can calculate. It is useful to locate the underwater hills, valleys, submarines, icebergs, and sunken ships, etc. Sonar is used to locate underwater hills, valleys, submarines, and icebergs, sunken ships, etc. So, ultrasonic sound wave is having this use also. What is that? To locate the underwater hills, valleys, submarines, icebergs, etc. So now we know what is sonar. Sonar is a short form of sound navigation and ranging. So you will get to label the parts. The diagram will be given. You will get to label the parts. What is the transmitter? What is the receiver? What are the waves which are transmitted and the waves which are reflected? And how can we calculate what is the time taken and what is the time taken for the transmitter to reach the seabed, or what is the time taken for the ultrasonic sound waves to reach from seabed to the receiver, or what is the total time taken, and what is the distance between the ship and the under seabed. All this way questions you can get for the examination. Not only complete experiment or complete description, in between questions, sub questions also, or labeling the parts, all this can be calculated. And you know what are the other uses of ultrasonic waves? It is used in the sonography, right? The last class you have already seen that video. What is sonography? The technique makes use of probe and gel. The gel is used to make proper contact between the skin and the probe so that the full capacity of the ultrasound can be utilized. We will do the remaining part of this lesson in the next class. Please open your textbook and see these parts what we have studied today in the class. Page number 133. Learn to draw the diagram and learn to label the diagrams and learn to label the parts, etc.